All right, you gotta hear this. What if I told you that a complete open source blueprint for a real deal, faster than light warp drive just dropped online? And I'm not talking about some fuzzy theory here. We're talking hundreds of pages of schematics, hard math, a parts list, the whole shebang. Well, you don't have to imagine it because it's real. And that's exactly what we're going to tear down today.
And this is the note the engineers left right at the end. I mean, talk about a bold claim, right? It's basically them throwing down the gauntlet to the entire scientific community. They're saying, look, every single component, every material, every process, it's all based on tech we can actually build right now. The big question is, how?
So to really get what's going on in this blueprint, you first have to understand the breakthrough that made it possible. For the longest time, there were two main ideas about how to do this, but they were totally separate. And honestly, they seemed completely incompatible, like they were describing two totally different machines.
So you had these two camps, right? On one side, you've got the engineers with their asymmetric quantum drive, or AQD. They were all about the physical stuff, the geometry of this plasma donut and how to amplify energy. Then, over in the other corner, you have the theoretical physicists with their inflationary entanglement resonator, or IER. They were deep in the weeds of harmonic frequencies and pure theory. But here's the crazy part. Look at the energy requirements. The engineers thought it'd take about 50 gigajoules. The physicists, they calculated 100 trillion joules. That's not just a little off, that's a 2 million times difference. So how on earth could these two groups be talking about the same machine? It just didn't add up.
The answer, the thing that connected everything, came from this single, absolutely brilliant insight. It solved the energy problem, it brought the two theories together, and it showed that everyone was just, looking at the same elephant from a different angle. And it all revolved around the most mysterious part of the whole design.
So, the early blueprints had this beautiful, really complex component. 7 nested shells, kind of like a Russian matryoshka doll, all rotating. And for a long time, the assumption was, these must be here to protect the crew. The idea was they'd smooth out the insane acceleration through something called frame dragging. And, kind of made sense.
But there was a huge problem. When they actually ran the numbers, the frame dragging effect from these shells was basically zero, a rounding error. They weren't a shield at all. And that created this massive mystery. I mean, if they're not for protection, why are they there? What is the real job of this incredibly intricate central piece of the machine?
And here's the answer: parametric amplification. The shells aren't a shield, they're the engine itself. The best way to think about it is like pushing someone on a swing. You don't just shove them constantly, right? You push at just the right moment, at that perfect resonant frequency, to add a little energy each time and make the swing go higher and higher. Well, the shells are doing that, but with the energy of the vacuum itself, pumping it up from one shell to the next.
And this is where it all just clicks into place. Suddenly, all these things that seemed like impossible coincidences made perfect sense. Both the engineers and the physicists were using the exact same 3 to the n mathematical progression. The rotation of the shells, it created the precise time-varying fields that the physics theory said you needed. The fact that there were 7 shells, well, that perfectly matched the 7 stages of amplification for a process they call a Bogolubov cascade. Even the spacing between the shells, based on the golden ratio, turned out to be mathematically perfect for transferring energy. It was just undeniable. They were describing the exact same machine all along.
Okay, so now that we know how the unified theory works, let's actually look under the hood. How is this incredible machine designed? What are the core pieces that make it all happen?
It really boils down to 3 main systems that all work together. First, you've got the plasma core. Think of it like a miniature sun, shaped like a donut that kicks the whole process off. Second, there's our matryoshka amplifier, those 7 shells, that takes that little bit of starting energy and pumps it up, big time. And finally, you have the emitter array, which is this beautiful, geometric flower of life pattern of 105 antennas that takes all that super amplified energy and shapes it to warp spacetime.
Now, let's talk about the spin, because this is where it gets nuts. The math showed that for this whole thing to work, that outermost shell would have to be spinning at over 500,000 meters per second. To put that in perspective, that's almost 0.2% of the speed of light. The g-forces would be, well, in the trillions. You could not find a material in the universe that wouldn't just shred itself into atoms. So game over, right? A catastrophic design flaw. Or was it?
And this is the solution. It's so elegant. The shells themselves,
the actual carbon fiber structures, they don't move an inch. Instead, they use a whole bunch of powerful, precisely controlled electromagnets to make the field rotate around the shells. You get the exact same physical effect, that time-varying boundary you need for the amplification, but without tearing the entire machine to pieces. It's just a brilliant, brilliant piece of engineering.
And this, right here, is the music the drive plays. It's this perfect mathematical harmony of frequencies. Each shell's field rotates exactly 3 times faster than the one inside it. It's this precise 3 to the n ladder that creates that parametric cascade we were talking about. It's not random at all. It's a super finely tuned resonance system. Each shell pumps energy into the next, building up from a low hum of 27 Hz to a screamingly high frequency of nearly 20,000 Hz on that last shell.
So you hear all this, a multi-million-dollar machine, mind-bending physics, and you think, how could you ever even start to test this? But what's so cool is that the unified theory also pointed to a surprisingly simple and pretty low-cost first step to prove the whole concept actually works.
Yeah, that number, that isn't the price of the drive. That's the estimated cost of the very first experiment. And that's huge, because it shows how accessible the proof of principle really is. Before you even think about the big build, you can test the entire theoretical foundation for about the price of an old used car. So what is this test? They call it Test Zero, and it's honestly genius. It uses sound waves in a tank of water, a science called cymatics, to create a big, visible model of the quantum physics happening at the core of the drive. The idea is really simple. If you can get sound waves, all synchronized, to create a stable, high-energy point right in the middle of that tank, you've just proven that the basic idea of amplifying energy through geometry and harmony actually works. And that's the roadmap. Test Zero is the big gateway. If that works, they estimate their confidence in the whole model jumps to 50%. And that justifies the next steps, testing magnetic versions, actually measuring the energy extraction, and then, the big one, building the first plasma prototype. But if that simple $10,000 water experiment fails, well, then the theory is wrong, and the project stops right there. It's a really clear, logical go or no-go plan.
So after all this incredible science, all this brilliant engineering, what are the real, honest-to-goodness odds that this thing could actually work? Well, the researchers actually put a number on it.
Their sober, evidence-based estimate is somewhere between a 15 and 30% chance of success. Now, I know what you're thinking. An 85% chance of failure sounds pretty bad, but in the world of bleeding-edge breakthrough science, those are actually amazing odds.
Let me put that 15% in perspective for you. The LIGO experiment, the one that first detected gravitational waves, it was given about a 15% chance of working. Finding the Higgs boson at CERN, that was pegged at around 30%. And getting fusion ignition to work at the National Ignition Facility, they figured that was maybe a 20% shot. And all of them succeeded. This project is playing in the same league as some of the biggest scientific discoveries in human history.
So that really just leaves us with one last big question. This isn't science fiction anymore. It's an engineering problem, it's got a clear roadmap, and it has a calculable chance of success. It might be a long shot, yeah, but what if they're right? What if we're in that 15%?